Welcome to Bexus Network, brothers and sisters. This is Brother Alfred speaking to the world. I'm going to deliver an urgent message to my American friends and my Asian Milk Tea Alliance. Because this is not only our problem, but can be your fatal problem in the near future. Hi, I'm a South Korean journalist who used to work at the mainstream media in South Korea. Now I stopped working for them and started working for you. I have interviewed 월터미베인 Jr., who is a professor of the University of Michigan. Dr. Mibein has revealed many fraud elections throughout the years. And these are the countries that turn out to be a fraud. Dr. Mibein recently wrote a paper called Frauds in the Korea 2020 Parliamentary Election. And this is becoming a vital academic resource because South Korea Central Election Management Committee won to the manual count, even though there were fraudulent data appears clearly. So I have interviewed Dr. Mibein, and here is full opinion on Korea election fraud case. He strongly suggested that we should do the risk limiting audits, recount the votes, and check the software if there was any fraud or hack occurred. Now the interview begins.
That there are problems in the election, and eventually someone, Hoon Chun, sent me pointers to a data set that I don't think he built, but someone else built. And I wrote a paper about it, which I posted, that apparently is getting a lot of attention in certain circles. And beyond the data that I analyzed, I really don't know much about the election or what's going on there.
Okay, so before we start the interview, I'm going to send you the sharing screen. Can you see it now?
Yes.
I've just sent it to you, and this is the paper you wrote.
Looks like it.
Right. So I want to talk about this first.
Okay. Well, as the paper says in my affiliation, I'm professor of political science and statistics at the University of Michigan. I also have an appointment as research professor, in the Center for Political Studies, also at Michigan, in the Institute for Social Research. And I guess I have some other affiliations, but those are the ones that can be important here.
Right.
The e-forensics is software that I created with support from the National Science Foundation, with a grant that ended August 31st of 2019. So the creation of that Bayesian program to implement a model that could detect frauds was the main focus of that grant, called a positive model of election frauds. It has a history. I've written a bunch of conference papers, especially in recent years with my research assistants for the grant, as we developed the e-forensics software. E-forensics is not the same as any of those papers. The last paper we had was a conference paper from 2018, but we made a lot of developments and changes in it during 2019. The version that's implemented in e-forensics is described in some slides I made for my class, undergrad class in the fall, called Election Forensics, which is my main research project. So for better or worse, probably for worse at this point, that set of slides is the only generally available description that's more or less accurate about what e-forensics does. It's pretty accurate. I assigned e-forensics as a tool for my undergrad students to use for their papers and in that class, and I've used it myself to write some of the things. I've applied e-forensics for more than 400 elections around the world and over the last 30 years or so of data that I happen to have. So I have a lot of experience with the model, and the main issues with e-forensics are the basic problem with what I call election forensics, which is the use of statistical methods to decide whether try to determine whether elections accurately represent the intentions of the electors. Is that anomalies and other weird things that happen in elections may be due to accidents, errors in various types, could be due to deliberate strategic behavior by voters or people who decide not to vote. And this would include things like big get out the vote mobilization campaigns, or strategically switching to vote for one candidate instead of another one because you think the one you really like is not going to win. And so this is the biggest challenge of discriminating weird things that happen for those reasons from frauds, which are the other kinds of things that you would like to detect, which I guess I'll call activities that are bad, that are pursued by some party or actor or administrator or somebody to disrupt the election counts. So the model itself, I don't know how much e-forensics is subject to being fooled by strategic behavior, but I do know that it can be fooled in the sense that it can detect things that it says are frauds that probably are not frauds. And so when I say in my paper that that's an important ambiguity, that's not just cheap talk. It's the frontier of research right now is to try to figure out how much frauds from that model or from any other model are produced by what I call normal politics, as opposed to being diagnoses of real bad actions.
I see. Most of people are not familiar with this statistic models of e-forensic models, right?
I would imagine not, because it's brand new, right?
Right, and it is very difficult to understand. So many people are asking me now that how accurate this e-forensic model is. I know you just explained about this e-forensic model, the accuracy about it, but most of people having a hard time understanding the exact accuracy. And when they look at your paper, they're having a hard time understanding the meaning of this paper. So they're asking me straightforward that, okay, so this professor, Dr. Mibain, telling us that there was a fraudulent intervene, or was there a fraud case in this election? That's the main question people are really questioning about right now.
Yeah, I sad to say can't really say more than what I said in the paper. Mm-hmm. And let me try to state that as clear as I can here, using overlapping but slightly different language. Mm-hmm. Which is to say that looking at the plots of the votes for the party leading in the constituency or the Democratic Party or probably any other party versus the turnout number. Right. And turnout, I should mention in the model, right, is a relationship between the number of valid votes divided by the number of electors. So many aggregation units, I'm not sure what to call them, so I'll keep calling them aggregation units in the data, have voters who voted, but their votes weren't valid. So those are not counted as votes for the model purpose. So looking at that plot, and that plots on these pages are the ones you went just by, this one can work as well. These are this pattern of diverse clusters of the combination of turnout and vote choice are very unusual. And so the one feature especially that the e-forensics model is designed to focus on is if you have different clusters of these combinations of turnout and vote choice. I see. And just right off the top, there are different clusters of turnout and vote choice, dramatically so. And in fact, the pre-vote clusters you can see have nearly 100% turnout, which is not the case for other clusters. And so it's not anything that's fraud that causes those pre-votes to be exceptionally high in terms of turnout. It's just the way that the system categorizes those. Similarly, if you look at the abroad votes, they presumably have a similar kind of structure, but there I saw that there are many higher numbers of abroad votes. So apparently there people cannot mostly self-nominate, but there are people who are registered to vote, but they are known to be abroad. But there are very distinctively lower turnout in the abroad districts. And the other two categories have different procedures that I don't know why they're different, but they also have some administrative rule that makes the turnout much different. And so that's not really the big issue. The other concern is that the proportion of votes, I believe the plot you have here is for the Democratic Party. The Democratic Party apparently got more votes in the pre-vote on average than they did in the other ways of casting the votes. And the question is, why is that? And I've read in emails, I've gotten various speculations about different supporters voting, but you can also see that the range of the votes in the pre-votes is slightly wider than the range in the other kinds of systems. And so it's not that all of the votes are higher for the Democratic Party in pre-votes. It's just kind of on average, they tend to be higher. And the question is that because Democratic Party supporting voters happen to vote using the pre-vote process more than others? And I've heard some argument why that is the case. Or is it, some kind of manipulation? And so that's a crude way of describing, just looking at the data, it's really challenging. So what I did in the way I specified the eForensics model was to include what I call covariates, measures of indicators for what is the administrative process that was used to produce each of the aggregation units. And so there's a separate indicator for pre-vote and for postal, so-called, and for election day, and for abroad, and for something called disabled ship, which I don't know what that is exactly, but it had also different characteristics. And so the main difference in the level of turnout or the mean difference in the votes for parties, those should be adjusted for in the model. And so the mere fact that pre-votes had much higher turnout than others should have no effect on the eForensics estimates. And there's a caveat on that I'll mention a bit further on. So the big visual thing you can see here with the diversity of these clusters should be removed more or less. And the question importantly is it removed enough to eliminate these administrative reasons to see these big differences in the votes?
Nice.
And so fraud detection is over and above that. Okay. The nuance that's important and is an issue that I've just had some email with someone who may know more about this than I do, is in the pre-vote pattern, there are those units shown in a diagonal going down the graph here, which have much lower turnout, but apparently the party, in this case the Democratic Party, got nearly 100% of the votes cast. And this kind of drags on for a while with lower turnout. And it's possible that those points are causing the rest of the pre-voted votes to appear to have excessive turnout. And that could be causing fraud signals. And if that's just an administrative error, I've seen it described as a clerical error. I have no idea. I didn't build the data that I'm using here. I just used data I was provided. And since I wrote the paper, I've gotten a couple of more data sets that I will when I return to this project in a few days. Maybe I'll try to check to see whether the data sets agree or whether the updated data set has the same feature. But that could be a reason why we're getting these signals for the pre-voted category, that there are many frauds in those votes. I don't know. It's possible. And so the argument there is that if you have what the original creators of that notion call frauds, it's because votes are added to a party, the leading party or the Democratic Party. I ran two kinds of specifications. And here you have to pick what party you want to allow to benefit from these so-called frauds. If you have excessive votes and turnout together in an aggregation unit, then that aggregation unit has a high probability of being marked as fraudulent. And so that's what's going on in the model. There's a lot of overlap between the units that are found as fraudulent for either of the two specifications I described, but they also disagree a lot, which is not really surprising. And so that's what's going on. The so-called fraudulent units are the ones that have excessive turnout and probably excessive votes for the leading party relative to an over-dispersed model allowing for extra variation beyond just thinking of each vote as kind of a coin flip with the probability set by whatever the mean vote shares or turnout is for each unit.
I see. So this is not your first time investigating.
I'll say one more thing about it, right?
Yeah, sure,
and
sure.
So this is why there's ambiguity about whether they're, really bad actions. The model can tell you when there are these excessive votes, but it can't tell you why.
I see.
So probably most people would say a real-world fraud is when someone did something bad to manipulate the votes or stuff the ballot box or rewrite the software or something. Well, that's one set of, or three reasons, I suppose, you could get excessive votes. The other reason you might get excessive votes is just a bunch of people decided to get together and let's all go vote, say the pre-vote, and we're all like the one party, and so they tended to choose that. So something unusual happened, and the one we just call get out the vote, and the others we'd call, real world malignant acts, bad actions. The model cannot say which of those are the reasons for the so-called fraud indicators. So this is why I say the model at best tells you there may be something to worry about, and so additional investigations are useful. I understand there are paper ballots in this election, so certainly one way to resolve a lot of these concerns, if they're there about electronic tabulation, is to do a manual count or to do a set of processes called risk-limiting audits, and that would largely resolve the issue of whether the paper ballot has been mistabulated by electronic means. That's generally a good practice to use in general, and so it would be, if feasible, useful to do in this and I'd say almost any other election that I can think about. And it may be that that's sparked by this analysis or other things people are talking about, but that seems to be a way to either rule out or show support for a lot of the allegations.
I see. So through your e-forensic model, you're suggesting us to change the election system in a way, right?
No, not necessarily. There's a lot of papers and organized actions in the United States to try to make risk-limiting audits a regular practice. And while some advocates of that practice think that electronic vote tabulation and other electronic procedures are just bad and should not be used at all, many also argue that what risk-limiting audits in particular can do is give confirmation about how well the electronic process worked. And so if you find a discrepancy between the results produced by a risk-limiting audit, well, the definition of a risk-limiting audit means if there's a discrepancy between the manual count of the random sample that is counted in the first place and the electronic tally, then the audit progresses to a full manual recount, and so you just have a full hand count, and one can decide whether they want to trust that process because it may raise other questions. But in many elections, what happens is that counting a relatively small proportion of the votes can quickly confirm that the winner did win, and so it provides more confidence about the election process that was used, and that by and large has been the overwhelming experience when this has been applied in the United States, though there have been a couple of elections that have been found to be problematic. So it would not necessarily change the election process. It's just a matter of answering critics who are raising these questions and providing concern to folks who basically do not trust electronics. And I'm in the camp that does not trust electronics. And so I think it's always a good idea to do something like a risk-limiting audit.
I don't know if you're familiar with this issue, but current South Korean regime claims that it is impossible to hack the electronic voting machine whatsoever. What is your opinion on this?
Well, I'm not a computer scientist, but I'm friends with many of them, and I don't know many computer scientists who have perfect confidence in the impossibility of hacking electronic technology.
Okay. You've also focused on not only Democratic Party on your paper, but also single-member district election data, right? On your e-forensic model research?
Yes.
And why did you do that?
Well, my general practice when I'm analyzing elections, and as I said, I've applied this, not only this model, but other models to hundreds of elections, is to consider that the candidate or the party that's most likely to benefit from frauds is the person who won. And of course, this need not be true, but all these methods can at most have one party or candidate committing frauds or benefiting from frauds. This is unrealistically limited, but this is the state of technology. And so the analysis where I look at all of the constituency winners is in line with my usual practice in analyzing data from all over the place. For example, I've looked at data from Canadian elections, US elections, and congressional elections, and all kinds of other elections. So I think in the paper what I referred to this is as a principled way of doing analysis is not to focus on one party, but to look at the winner in each of these constituencies.
Right.
In addition, because it's a single-member district, you have different kinds of strategic dynamics because the voters want to have a candidate they support win, and so in each district it may be that candidates who are not that strong lose votes because their supporters decide to vote for their second choice in order to defeat an inferior candidate. And so the dynamics that go on in each district in single-member district elections very often mean that the different districts are really different from one another. So the models I did, which are my B models here, I guess I call them B in most of the tables and figures, is the one that does the constituency level analysis. And if I were just taking this election just because it's a cool election and it's really interesting and I happen to get data, and this is kind of what I do for my research, then I would have just done the constituency level analysis. However, the people who reached out to me first with the data said there were these allegations against the Democratic Party, and so I did that too. And I don't know, because I don't believe the model is perfectly correct for some of the reasons I just said. And certainly looking at data analysis, one doesn't have any presumption about who is benefiting from frauds. And so the two models reflect the kind of two different, I guess you call them audiences when I was doing the paper.
Right. And to be more clear, you've mentioned that almost 1.4 million votes were fraudulent all over Democratic Party on your paper.
Yes.
What does it mean by that?
Well, what that means is that the model found, I referred before to the excessive votes and excessive turnout compared to, and now I have constituency fixed effects, which is an indicator variable for all of the constituencies included in the data. And I should add as a footnote, apparently the data are missing a constituency.
Right.
So I'm not really sure what's going on there. But I think I have, 252 constituencies. And so the Democratic Party, the model says, had 1.4 million of those aggregation units where some combination of turnout and votes for the Democratic Party were too high. And again, as I mentioned, the model does not say anything about why those points are too high, and so all the interpretation and so forth depends on further data and information and other kinds of investigations.
So, do you find this case interesting? This 2020 parliamentary South Korea election?
As a scientific matter, it's certainly interesting, but I'm interested almost always in every election I can look at where I can get such data. The quality of the data are still a bit in question because of some of the anomalies that are apparent in the plots that I'm told shouldn't really exist, and some other surprises there, like the apparently missing constituency, which could be my fault, or it could be that the data I got are missing them for some reason. I'm told the data I got were downloaded from a, I assume, government election commission website. I did not do that download myself, and so I don't know, maybe the data are missing on the website, or I don't know what's going on. So as a scientific matter, one certainly needs to validate that the data are good data to study, and I believe there's a few open questions about that right now. But for my scientific purposes, this is an amazing election because of the great diversity as evident in the first couple of plots you showed in this period, with the big different clusters of votes with very diverse turnout levels and different supports for the parties. I've very rarely or never seen data that look like that. And so this would be very interesting to try to figure out scientifically what's going on here, to develop improved processes for diagnosing elections in the future, or possibly deciding that the mission of diagnosing elections using statistical models is just too hard to do. I think the jury is still out about that, but I think this election certainly is scientifically interesting. I don't have a big interest in Korean politics generally, so in terms of my caring about the parties and who wins and so forth, my research does not address those kinds of questions. I'm sure every Korean cares about those kinds of questions, and I know that's really why this is important. And the general notion of trying to help legitimate elections by using scientific methods to rule out or maybe validate allegations about accidents or frauds. I've written papers about accidents or in the United States elections that, for my argument, produced the wrong outcome for like the presidential election. So I'm not any stranger to big problems like that coming up. But I don't have a particular interest in the Korean election from that point of view.
I see. Are you planning to build up the case, build up the research and maybe the model in the future with this Korean parliamentary election case?
Most likely. Right now here at Michigan, it's the end of semester, and I've got to, immediately after I get off this call, grade a bunch of papers. So I'll spend the next couple of days grading and finishing up with the end of semester activities. Maybe starting on the weekend or later, I hope to first reconcile the different data sets that I now have. As I was finishing the analysis, I received several different maybe versions of the data, and so I need to figure out what those versions are and try to see what the consensus, or maybe do the analysis using all of them to see if they all agree. So that's the first thing I'm going to do right away, and probably after I do that, in the short run, I'll issue another version of the paper, maybe sometime next week, reporting on either the diversity of results or saying this is the one I think is the right one. And then probably I will put this down for a while and return to use it as a case for my research in some way, but I haven't thought about how to pursue it further into published, hopefully peer-reviewed work.
Okay, thank you for the interview, Dr. Mibein.
Okay, thank you. My pleasure.
And thank you for your great work.
Well, some people think so, but others apparently don't like it. So there's a diversity of opinions. But it's an election, so I'm not unused to controversy. I won't tell you the stories about various things I've gotten involved in.
Okay. So it seems like you're in a hurry, so I'll let you go this time.
Okay.
And we'll keep in touch.
All right. Thanks. Bye.
Thank you very much.
Audio Jungle.